going to step aside as we pay tribute to the newest and largest member of the Boeing family of airplanes, the 747-400.
We are living in an air age. International travel is a multi-billion-dollar business. The world airlines carry many millions of passengers every year. A Boeing 747 jumbo jet carries nearly 500 people across the Atlantic in around 7 hours. The supersonic Concorde makes the same journey in around 3 hours. Rivalry between the airlines for passengers is fierce. But behind the scenes, the rivalry is even more intense between the aircraft manufacturers. At stake is more than money. It's national prestige. It's pioneering new technologies. Aerospace companies are vital to the future of advanced economies. The flight across the Atlantic has been the blue ribbon of the airline industry for over 40 years.
Heathrow, Britain's £20 million airfield, is opened by Lord Winster.
This proving flight starts off from Heathrow, which will be the future civil airport of London. And it takes off from the finest runway in the world.
The rivalry started after the war. Britain's only long-haul airliners were converted bombers. They were slow, unpressurized, and noisy. America had built transport aircraft like the Lockheed Constellation during the war. When Atlantic services started in 1946, European airlines were forced to buy American to compete for the small number of passengers.
After the war, in the late 40s, I don't think the normal person ever thought about flying. Rich people, poor people, students, all went by ship. That you spent 2 weeks on the ocean.
The largest and most luxurious of the American piston-engine airliners was the Boeing Stratocruiser.
There was one time when I had to take a prop plane, and I looked at the safety record of all the lines, and far and away the best was Lufthansa. And we left what was then Idlewild at 5 p.m. And it was absolutely splendid until the dusk came on and we lost a starboard engine. And the steward came up to me and told me about this, and then the lights went. I said, perfectly all right, we can land in the Azores or somewhere. And then he came back and said the one on the port side is gone and there's no possibility. So we turned and limped into Gander.
Most airline passengers in the piston era were either wealthy people or businessmen. They expected high standards of service on board, and staff had to be carefully selected.
One question they always asked is, have you done any amateur dramatics or acting? Which, of course, was a test one to show you didn't mind being in front of people. The British, remember, were in international competition with the Americans in those early days. So one was trained to give all the best service you could, particularly with the food. The bar was very popular. That was a good selling point for Stratocruisers. And not everybody wanted to go down there, because if there was a lot of men down there telling stories or a naughty party going on, maybe the old ladies who still wanted their gin and tonic didn't want to go down there. So the stewardess had to go and fetch drinks and carry them up and down the stairs. I think some people thought it was dangerous and were still frightened. I mean, my mother dined out for years on the fact that her daughter was a stewardess flying the Atlantic, and everybody said how brave I was.
And I myself was very, very leery of flying. I hated flying until the jets came in, because you flew through the weather. And so you didn't have somebody saying, would you mind keeping your belts loosely fastened because we may hit a little turbulence? I mean, I crossed the Atlantic once when there were about 10 hours of turbulence, you know.
Crossing the Atlantic in these gentle giants took 14 to 18 hours. But even so, passenger traffic grew steadily. And since Europe was still without any comparable aircraft, Lockheed, Douglas, and Boeing sold hundreds of the piston engine transports worldwide. But in one aspect of aviation, Britain still led the world in the late 1940s, the jet engine. In 1948, the de Havilland test pilot, John Cunningham, set a new world altitude record in a jet fighter. He reached nearly 60,000 feet high above the turbulent weather. To challenge American dominance, Britain decided to take a brave technological step. The de Havilland Company designed the world's first ever jet airliner. It was to be called the Comet. Jet engines give passengers a faster, more comfortable flight. The higher they fly, the more efficient they become. The reverse of what happens with piston engines. A jet-powered airliner would fly above rough weather. The prototype was ready for its first flight in 1949. Frank Whittle, the inventor of the jet engine, was there. The test pilot was John Cunningham.
Well, I made the first flight at Hatfield, and it worked extremely well. It was a very nice aeroplane, a very gentlemanly aeroplane, and as a pilot, it was a real joy to fly it. The Comet, of course, was so far ahead of any other transport that we were on our own out in front, and we had no one else we could look to for their experience. We had only got our own experience.
The world's first jet service to carry fare-paying passengers started in May 1952 from London, in stages, to Johannesburg. The Comet lacked the range to cross the Atlantic, but it seemed to be heralding a new age in air travel.
The Comet set a standard that at that time, in 1949, meant that passengers could fly at twice the speed of the then best airliner, which was Lockheed Constellation, and more than twice the height, in very smooth conditions, and to be able to consider taking passengers or going from here to Johannesburg in less than half the time of the best propeller-driven transport opened up a wonderful field of smooth, comfortable travel.
Longer-range versions were planned. With its technical lead, the future of Britain's aircraft industry looked assured.
We were naturally delighted to be the leaders of the air transport business, and our plans for the future, which were going ahead in quite a big way because we were still years ahead of the Americans, were brought to nothing when the Comet failures grounded the Comet in 1954.
The future of the Comet, the world's first passenger jet airliner, hangs upon the outcome of a court of inquiry being held at Church House in London. This is some of the evidence.
The Comet fell out of the sky, literally, over Elba. We did not know at the time why it had come down, and after a period of grounding and investigation of possible causes of the failure, they were allowed to fly again. About a month after they had started flying again, a second one came out of the sky in the Bay of Naples, and the Comets were then grounded.
I think to the public it was quite shocking because the Comet was a lead aeroplane. It was unique at that time, the only jet aeroplane flying on public service. And at the start of these investigations, we really had no idea whether we would ever get any large amount of debris.
The Royal Navy managed to salvage 80% of the Comet from the seabed. The wreckage was taken to Britain and reassembled at Farnborough.
Here was an aeroplane designed by very competent people, being operated by very competent operators, which had fallen out of the sky twice from high altitude and killed a lot of people. So it was a very dismaying thing in engineering terms. On the other hand, I suppose the professionals at the time were a little more used than they are now to aircraft disrupting. That many years ago, we had to deal with these things much more often, thank God, than we have to now.
One of the grounded Comets was taken to Farnborough to be tested to destruction. The fuselage was encased in a huge tank which was filled with water. Water was also pumped into the pressure cabin. It was pressurized and depressurized continuously. At the same time, the wings were flexed repeatedly by hydraulic jacks to simulate the conditions of flight. The aircraft survived these tests intact for the equivalent of 15,000 hours flying before the fuselage burst.
The conclusion was the accident had been caused by a fracture of the pressure cabin, which itself was caused by a fatigue failure in the metal near the corner of a window. That failure had spread very rapidly down the cabin and leading to an explosive decompression, which caused the aeroplane to break up. We particularly wanted to see if we could get the part of the real airplane from the bottom of the sea to check this. We therefore made some models which broke up. We were able to break up in the air in the way we now thought the aeroplane had broken up, and to carry out flight experiments to see where the parts of the model fell. In this way, we were able to tell the Navy, roughly speaking, where to look for the actual part we were interested in, and they got it within an hour or two of searching. We got that back to the laboratory very rapidly, got it under a microscope, and there was what the Attorney General in the Court of Inquiry called the fingerprint of fatigue. Well, I suppose a new word came into public parlance, metal fatigue, because it hadn't been heard of very much by the general public before this, though in the engineering profession it was quite a well-known phenomenon.
We were pioneers, and the world has benefited by our failures, but de Havillands lost the enormous advance they had in position ahead of the Americans, but the world has safer jet transports today.
The afternoon of May 15, 1954, Mrs. William E. Boeing, wife of the founder of the Boeing Airplane Company, christened a new airplane. Then America's first jet transport, the Boeing 707, was towed into the sunshine.
The 707 was a private venture. The Boeing chairman, Bill Allen, had put $15 million behind the project. But if Boeing took a financial risk, it took no risks with the design and building of the 707. Its metal skin was over 4 times thicker than that of the Comet. Boeing drew on its experience with America's first jet bombers, the B-47 and the B-52. Both had been flown by Boeing's chief test pilot, Tex Johnson.
After flying the B-47 and the B-52, there was no doubt in my mind that the aircraft of the future, military and civilian transportation, was going to be jet. Of course, the prototype 707 was all built with company money, and it was a big responsibility. It was a gamble to some degree from a structure standpoint and a performance standpoint, but not nearly as much as the gamble of how long is it going to take the airlines to decide that's what they wanted and come up with the money to produce it.
Tex Johnston, chief of flight tests for the Boeing Airplane Company, signed for the new jet transport and climbed aboard with Dick Flesch, his co-pilot.
The first flight was on the 15th of July, 1954. Tex Johnson's family was at the Boeing airfield near Seattle to watch him taxi out.
with half of Seattle out there observing it, and all of the industry, airlines, engine manufacturers, competition looking down your throat, you had a lot on your mind. But once you fire up the engines and taxi out for takeoff, all that leaves you, and you're primarily absorbed in all the systems in the airplane, how it's reacting to the control. And as we taxied out, the people were jumping up and down and waving, and it was a celebration.
707, we're clear to come up on power.
Gave it the power and took off, and it rotated, and the first liftoff, the airspeed just kept building. I kept pulling the nose up, and we were light, relatively light, you know, and we were climbing steep. And my co-pilot, Dick Sledge, said, "Man, is this thing going to climb straight up?" And after I landed, some of the engineers said, "We thought something was wrong with the control system. The airplane was climbing so steep. All I was doing is keeping on the best climb speed."
Flight messenger reads, this is Tex. We've been climbing for 8,700 feet. All engine operation is normal. Hydraulic pressures are normal. The airplane feels good.
The airplane taxied in, and when it had been parked, the pilot and co-pilot were congratulated by William M. Allen, president of the Boeing Airplane Company.
I could see the difference in that man from he shook hands with me before I climbed aboard on the initial flight. And to me, it looked like he was carrying a bit of he was stooped a bit at a load he was carrying, mentally, financially. And when we landed at Boeing Field and he came out there, he was standing straight and tall and smiling, and it was beautiful to witness the difference in the man.
The test flying program for the 707 lasted 4 years. Tex Johnson had his own way of thrilling airline executives with demonstration flights.
IATA, the International Air Transport Association, which includes all the airlines of the world, had assembled in Seattle for their annual convention. And Boeing just happened to have a prototype airplane that was going to shrink the world by a factor of 2. But I've sold fighters and commercial airplanes, and you demonstrate them to impress people what they're capable of. And I knew that the prototype, and there's one maneuver that you can do with no hazard whatsoever. I decided that I would do a roll to impress the people. So I came across and did a chandelle. One of my test engineers happened to have his camera with him, and he snapped a picture, which is famous today, with the airplane on its back and the engines up on top of the wing, and the Lake Washington below. I was called to Mr. Allen's office Monday morning, and Mr. Allen asked me what I thought I was doing, and I said I was selling airplanes. And explained it's a 1G maneuver, and it's absolutely non-hazardous, but it's very impressive. And his comment was, you know that now, we know that, but just don't do it anymore. So it was fine.
The first Comet intended for North Atlantic service was officially handed over by the de Havilland Company at London Airport to British Overseas Airways. It was an historic day.
4 years after the crashes, the new Comet was ready in October 1958. At the same time, Boeing delivered the first 707 to Pan American.
America's first commercial jet airliner, the $5 million Boeing 707, makes its debut at New York's International Airport. Due to enter the New York to London service on November the 1st, it will usher in a peacetime Battle of the Atlantic with Britain's Comet 4. The Boeing will carry 165 passengers to London in 6.5 hours. A British rival, the Comet 4, carries less than half as many, but in some ways, mere size is a disadvantage.
But the Comet was too small and too late. The airlines preferred the 707. When Boeing introduced the longer-range Intercontinental 707, even British Overseas Airways had to buy American to stay in the race. The 707 fathered a family of smaller jets, the 727 and the 737, which served the domestic routes. America's dominant position was unchallenged as the world entered the jet age.
One of the early jet pilots said, crossing the Atlantic is now 6-7 hours of boredom enclosed by 2 separate minutes of panic, getting in the air and getting down.
Flying was still a fairly exclusive way to travel.
People always say, who did you meet in the 60s? And they suggest things like movie stars and so on. Well, I never traveled first class, so I don't know. But I did see them occasionally coming out with their bandboxes and waiting at the carousel for their 58 pieces of luggage. This was true, for instance, of Ronald Reagan, when he was never a great movie star, but the only time he performed in London, when he got to London, he found he couldn't get either the chili that he wanted or the hamburger or whatever it was. I think it was chili. So he gets on the telephone and has a famous restaurant in Hollywood fly the chili in the next day. That was a sign of great status with him, because it was a big nuisance to everybody else, but it showed status.
Flying was still beyond the pocket of most people. But Boeing was already working on a new aircraft which would change that. In 1966, Bill Allen of Boeing gave the go-ahead for the biggest civil aviation project ever, the Boeing 747 jumbo jet. Later, the same year, Juan Trippe, the visionary head of Pan American Airways, ordered 25 of them off the drawing board.
But 747 definitely was a vision of two men, Bill Allen and Juan Trippe, who wanted to finish their careers with something that would obsolete just about everything else. It was a tremendously gutsy decision. It was even more gutsy than either man realized because of the monetary significance of the project. And we had to build a new factory as well as a new airplane.
Bill Allen bet the company when he made the decision. That's how big it was. So if the program had been a failure, it would have wiped out the Boeing company.
To build such an aircraft, Boeing drew again on its long experience. It was an impressive technological achievement, but the real gamble lay in its sheer size. It would revolutionize air travel, but only if people flew in sufficient numbers to make it profitable. Allen set his engineers an almost impossible schedule: to have the 747 flying in 2.5 years. The first 747 was rolled out of the factory almost on time, to the delight of Bill Allen. The world's major airlines were there to congratulate Boeing and to see for themselves the aircraft which would usher in an era of mass travel across the Atlantic and around the world. The first flight was only a few weeks late. In February 1969, the 747 was handed over to its test pilot, Jack Waddell.
My son walked out with my parachute on one side, and Bill Allen walked out on the other side. And he said, Jack, he said, I hope you understand that the future of the Boeing company rides with you today. The first flight had been planned to be very ambitious. We were going to fly 3 or 4 hours and do all kinds of things. The weather was quite marginal, and I was very anxious to get the airplane off. We took off and circled the field for photographic reasons, and then flew out toward the west where the weather was better. Mainly just learn how to fly the airplane.
Along here, heading 240.
After a few maneuvers, mainly for my familiarization, and to check the system to see they all worked, we decided to change the flap setting. And when I moved the flaps from the takeoff to the next flap position, we got a very loud bang in the airplane, enough to startle us somewhat. There were just 3 of us aboard, the 2 pilots and the flight engineer. So I sent the flight engineer back to see what had happened, and this big Venetian blind flap we got, the center segment, had come loose on both sides of the airplane and slid down against the back of the flap. This caused us to terminate the flight early. I had the F-86 fighter tucked right in, and I used my good friend Paul Bennett, and I said, Pablo, I said, you be sure to tell me when I'm past the end of the runway and how I am, and he helped me. I actually contacted the ground a little before I expected to, but on the film, the landing looked smoother than it really was. But later on, with more experience, I wouldn't have been proud of that landing.
Okay, Jack, natural question is, what are your impressions?
Well, Al, I guess this sounds complacent or something. That thing is just ridiculously easy to fly. It's just a pilot's dream. Really a nice airplane to fly.
A year of intensive testing followed the first flight. The wingtips on this 747 flex through several feet from the impact of landing at over 5 times the normal rate of descent. Here, the test pilot deliberately takes off at too steep an angle, putting the tail of the jumbo in contact with the runway. The tail is protected by a wooden skid. The purpose of the test is to make sure that the aircraft can continue to accelerate even under such harsh conditions and still take off successfully. It's just as important to know that a fully loaded jumbo weighing over 300 tons can be brought to a halt on the runway if it loses engine power at takeoff speed. In this test, maximum braking power was applied. For certification, the aircraft then had to sustain the fire for 5 minutes to give the emergency services time to arrive. Taxiing the jumbo from its cockpit high above the ground was a new experience for airline pilots. Some doubted it could be done at all. So Boeing rigged up a truck to simulate the dimensions of the 747 to give them some practice. No major airline could afford to be without the jumbo. By the time it was certified for passenger service at the end of 1969, nearly 200 had been ordered. A new jumbo was leaving the production line every 5 days. Bill Allen's gamble was paying off. So was Juan Tripp's. Pan American made the inaugural flight across the Atlantic from New York to London in January 1970. Today, the jumbo sets the standard on all the world's air routes.
Good afternoon, everyone. This is Captain Mike Wakeford. I hope you enjoyed your lunch earlier on this afternoon.
When I first started flying commercially, that's after I left the Air Force in 1956, we had a 5-man crew. We had pilots, engineers, navigators, radio officers. And now it seems, particularly relative to the 747. The aircraft got very much bigger, whilst the cockpit and the flight deck crew got that much smaller. When we arrive in Los Angeles, the aircraft will be on the ground just a couple of hours or so. It will be turned around, having been refueled and serviced by maintenance people on the ground there, and it will be on its way back to London, where it will arrive tomorrow afternoon. Again, the same thing will happen. It will be turned around at Heathrow, and off it goes. The utilisation rate, something like 14 hours, or perhaps a little bit more than that per day, every day. In the 12 years that I've been flying this aeroplane, I've only had 2 occasions to have to shut down an engine, just one engine on each occasion, which I think is a pretty good record. It's a very, very nice aeroplane to fly. It's certainly a pilot's aeroplane, and I think for that matter it's a passenger's aeroplane. Because of the size of the cabin and the breakdown into cabin areas, one doesn't get that effect of being in a tube, an aluminium tube. We have 360 passengers on board, who at this very moment are watching the onboard movies that are being shown, and a different film, I might add, is being shown in each of the various cabins. And that's not just on board this aeroplane. There are 40 or 50 other 747 aircraft at this very moment crossing the Atlantic eastwards and westwards with similar numbers on board, doing very much the same thing. And this is an everyday, commonplace occurrence.
In the battle to win passengers on the Atlantic, European manufacturers chose a different route. Instead of size, they decided that speed was the essence of air travel. To get back in the race with America, Britain and France decided to pioneer new technologies to build a supersonic airliner, the Concorde.
It was very radical. It really required a new approach to every part of the aeroplane. We could start off with systems that were essentially fairly conventional, but then we had to make them work in these rugged environments of high temperatures, high speeds, high altitudes. The engine intake was a very substantial part of the development program on Concorde, because in simple terms, the engine can't accept supersonic air going into it. The engine is designed to operate with subsonic air going into it. So even when Concorde is doing Mach 2, you have to find some way of slowing the air down so that it's presented to the engine face at roughly half the speed of sound. But you've got to do it efficiently, otherwise the fuel consumption would be horrendous.
Developing Concorde's engines and air intakes was done by fitting an engine into the bomb bay of a Vulcan bomber. The shape of Concorde's wing was another technical frontier which had to be explored. Britain had done a lot of research into the properties of delta wings in specially built research aircraft. A delta wing was chosen for Concorde. It had to be the right shape to cruise at over twice the speed of sound in the stratosphere, while remaining safe close to the ground at normal landing speed. More data about the performance of the wings was obtained from wind tunnel experiments in Britain and France.
The breakthrough on the wing was to come up with a shape that gave us the combination of quite acceptable landing characteristics and very good supersonic efficiency. And the shape of the wing, both in its plan form and in its leading edge, are a major breakthrough. We were facing a new regime of flight which nobody had experience of on civil aircraft, and even on military aircraft some of the experience was quite limited. So we had to prove that the aircraft was safe at very high altitude, very high speed, very high temperatures. We had to prove that the materials could stand the loads, that the systems would keep the cabin cool, and that's where we used the fuel to keep the passengers cool. The heat from the inside of the cabin is put into the fuel. makes the fuel hotter, but it keeps the cabin cooler. Cool enough to be just as comfortable as any aircraft you'd like to fly in.
Concorde's droop nose was another pioneering step. The cost of developing these new technologies was high. It was borne equally by the French and British governments.
We first of all tried to get America to join with us, but they wouldn't have it. They were only interested in Mark III. The speed of the aircraft, odd enough, was fixed by the materials used in the aircraft construction. The light alloys deteriorate with increasing temperature, and at the temperature of about 120 degrees is about the limit of deterioration that you can stand over the life of an airplane. At 120 degrees, temperature rise corresponds to Mach 2. So Mach 2 becomes the highest speed that the airplane should be allowed to fly. We never understood why the Americans wanted to go at Mach 3. It was altogether too difficult.
Building Concorde in two countries, speaking two different languages, was difficult enough. Both France and Britain had assembly lines, and the parts had to be ferried between the various factories in the two countries. In an extraordinary aircraft, the Super Guppy, a converted Boeing Stratocruiser. It hinged in the middle of a cavernous hold. Concorde was built amid continuous controversy. Development costs rose to over 5 times the original estimate. When the prototypes were rolled out in 1967, there were already doubts about its economic viability. But they were largely ignored as the first flight approached, and there was a feeling of enormous pride in the technical achievement. The world's airlines showed great interest. Once again, it seemed that they would have to buy Concordes and go supersonic to compete for the VIP passengers on the Atlantic. Behind the public relations exercise, French and British test pilots were working up for their first flights on simulators.
The simulator gave us ideas that in one or two areas the airplane was difficult. And as it turned out, the airplane actually was very much easier to fly, which was one of the pleasant surprises which came quite quickly obvious to us.
Brian Trubshaw and his crew of 6 are taxiing towards the turning circle.
The first flight on 002 was quite exciting because we'd had some failures of our airspeed indicator. So having got it fixed, I thought, well, if it works this time, we'll go, and that's what we did.
Full power and reheat. Beautiful takeoff. Climbing steeply, reheat still on, I can see. 2,000 feet he plans to cut reheat.
The French prototype 001 had flown a month previously. 002's first flight lasted just over 40 minutes.
When we arrived at Fairford, both our very sensitive altimeters, radio altimeters they're called, failed. So the first landing had to be done without the benefit of this very accurate height information. But it was all right. We arrived perhaps 1 second early, but didn't damage anything.
It was 7 years before Concorde carried fare-paying passengers. Only Air France and British Airways turned their options into firm orders. In 1973, the massive increase in the price of oil cast further doubt on its economic viability. And then it was barred from operating on the route it was built for, the Atlantic.
That abomination will never, never land at JFK Airport.
The building shook. I held my ears. We dread one flight over our heads. If the French and the British made a mistake, with this plane. We're sorry for them. But we do not want to and should not be forced to live under these conditions in the flight paths to Kennedy.
I'm quite clear in my mind that if the American SST had survived, then the opposition on grounds of environmental issues would have been totally different. They would have been suppressed, and I will always be convinced that that was the case.
Tomorrow, the future. Because tomorrow, British Airways introduce Concorde, the first supersonic passenger airliner to fly you at more than twice the speed of sound. Concorde has crossed the Atlantic in 3.5 hours.
Only Britain and France bought Concorde. 16 aircraft were built. The first supersonic services were to South America and the Middle East in 1976. The following year, the American authorities let it land in the United States, and Concorde began carrying passengers across the Atlantic. In speed, Concorde has no rival. It routinely carries passengers over the Atlantic as fast as a bullet. But it has a rarer quality, the means to inspire. After years in service, heads still turn when it flies, and people are moved by its grace and beauty.
Ladies and gentlemen, it's Captain Walpole up at 28,000 feet now, just coming up over the Bristol Channel. And it's over the channel that we'll be carrying out the transition from subsonic to supersonic flight. That's just 10 miles away from here. And you'll be able to follow the acceleration of the flight information system at the front of the two cabins as the aircraft accelerates smoothly through Mach 1, the speed of sound. We'll be achieving Mach 2 as we pass through 50,000 feet. And we'll be putting that little lot together in just 30 seconds from now.
Here we have this incredible aeroplane performing at these great speeds, but from a passenger's point of view, it is a smooth non-event. A magnificent example of that was on the proving flight on the way down to Bahrain. A passenger came up to the principal designer and said, what's all this about twice the speed of sound? There's no drama, there's no bumps and bangs, no excitement in it. And the designer merely turned around and said, yes, that was the difficult part in the design. It gives the airline, firstly, a unique product. Secondly, it attracts to it very high-yield traffic, i.e. that the upper echelons of the business world are our prime clients, and that must be good for the airline. We have got the people who are prepared to pay the premium rates for Concorde. And bear in mind that Concorde saves them time and saves them condition. And there is one thing that you cannot buy in life, and that is time.
Concorde has never been a challenge to the dominance of American manufacturers in selling long-haul aircraft. 20 years after the first jumbo jet was rolled out, the latest model, 747-400, was given the same spectacular treatment. It'll be dominating the Atlantic well into the next century. The basic design has been improved. It can carry more passengers over longer distances. By keeping fares low, the jumbo has become the people's aeroplane, bringing worldwide travel to a whole generation. The price is around $120 million, but Bill Allen's gamble is still paying dividends. Over 100 aircraft have been ordered before the first flight. But the first signs of a new European challenge to American dominance are at hand.
C'est un grand plaisir pour moi d'appuyer
sur ce bouton rouge et il me semble un peu dangereux.
Concorde was an economic absurdity, but its legacy of cooperation between European nations has borne fruit in the Airbus consortium.
All the Airbus aircraft are collaborative aircraft, and that means the bits and pieces come together from the four partners. We make the wing, for example, in Britain. The Germans make the fuselage, the French make the flight deck, the Spaniards make the tailplane, and they're joined together in Toulouse.
We started right from scratch because we had to realize a European product meeting the world airline demands, and we took, in certain areas, a daring type of approach. We decided to look for a high-capacity airplane serving short and medium-haul ranges with 2 engines only, which certainly at that time was one of the most daring approaches that were ever done in that field.
The latest Airbus, the A320, is too small for the Atlantic. But it is part of a family of airliners, and its larger stablemate, the A340, with 4 engines, is destined for the Atlantic route. Once again, Europe has concentrated on advanced technical concepts. The aircraft is controlled by computers. The control column has been replaced by a side stick. The system is called fly-by-wire.
This is the beginning of what would be a classic stall maneuver. And now, as far as the fly-by-wire is concerned, I simply pull full up elevator and maintain it, and the system completely looks after the airplane on its own. There we are with 28 degrees of pitch attitude. Speed reducing to about 90 knots at the moment. The angle of attack is stabilizing at 17 degrees. That's the stall warning, which is cut in there for the moment. And the airplane is now stable. We have a stable altitude, stable pitch attitude. Speed is 94 knots. You may see it moving very slightly as the system takes care of the little bits of turbulence that we have here at 10,000 feet.
Competition to sell aircraft is intense. One of the world's foremost arenas is the Paris Air Show. Manufacturers come to close deals worth hundreds of millions of dollars.
And we would like to replace those aircraft for a new type, new generation type of aircraft. And we would like to know really what are advantages over the competition.
I believe we have very significant advantages over the competition. 7J7 interior is based on a 188-inch cabin. That is 32 inches wider than the Airbus A320, and it's 10 inches narrower than our own 767. We have a personal entertainment system in the back of every seat, so you can select a TV, stereo, or other information that's available.
Air shows are just a focus for the manufacturers. The real battle for sales goes on all year round.
It has to be recognized that Airbus industry practically has all new products. Compared, for instance, to the United States, to our competitors who at present make all their commercial successes based on quite oldish types of airplanes which were designed 20 to 25 years ago.
The next great step for mankind in commercial aviation could be into space. America has put national resources behind its national aerospace plane. Europe has designs for a comparable machine. The question is, does mankind need to take that step?
I don't believe there's much farther to go inside the atmosphere because of the limitations imposed by the atmosphere itself. The environment won't tolerate noise to the levels that people once dismissed as not being important. I mean, I can't imagine that I would like to live in a world that was absolutely filled with sonic and continuous sonic booms, for example. Then we have to go outside the Earth's atmosphere. We have to go exo-atmospheric. Whoever gets there first, I believe, and is capable of developing this system, should have a world lead, the kind of world lead that we should have had with Comet if we got it right. And we could have had up to a point with Concorde. But there is another great opportunity coming.
Many people believe that a space liner can only be built with global cooperation. The reason is cost. The days when Bill Allen and Juan Trippe gambled on the future are over.
Well, the goalposts, I think, have changed in the sense that the product has got to make economic sense first. Just because you can do it technologically will not be good enough. It was probably good enough for the 747 that you could do it technologically, therefore you did it, which essentially is a carryover of the barnstorming mentality of the air transport and the air manufacturing industry from the 20s on. That has changed in that it's become a business, and businessmen run the businesses.
Boeing has been in the business a long time. With half a century of experience, their view of the future is conservative but confident.
I think Boeing has more technology than Airbus. They just don't advertise it. Fly-by-wire is way overstated as to the benefits that you get economically. And nobody's going to buy an airplane just because it has fly-by-wire and another one doesn't.
The phenomenal step that occurred from piston engine, propeller airplane to the jet, I don't see repeating. There'll be a lot of arm waving, but fundamentally, there will be improvements on what we have today. I would love dearly for the vast majority of people say what they really want to do is fly on a Boeing airplane. In fact, when you come down a jetway in a typical modern airport, it's very difficult to tell what kind of airplane you're on. I suppose that's one of the prices of success. You know, if we only sold 3 airplanes, it'd be a very glamorous thing, because only a few people would ever get to do it. We've now got over 5,000 jet transports, and we move millions and millions of people. And that, by its very definition, takes some of the glamour out, because everybody does it.